B. This is known as mechanical energy. Kinetic plus potential, this sum is known as mechanical energy. Hello friends, today we will discuss on motion in a vertical circle. Many a times questions has been asked from this particular topic in erstwhile AIPMT as well as NEET also. So let us discuss this concept through few problems. The first problem that I am taking is a problem that was asked quite a back, I guess in year 2003 in AIPMT exam. This was the question. The question reads as, there was no diagram as such, the question reads as, there is a particle tied to a string and it is moving in a vertical circle like this. The length of the string is L. The particle is going in a vertical circle like this. The question says that at the lowest point the particle has a velocity u. At the lowest point the particle has a velocity u. What is change in velocity when the string becomes horizontal? When the string reaches this position, by the time string reaches this position, rather the pendulum bob moves from position A to B. What is change in velocity? Find change in velocity by the time the pendulum reaches to position B. Now first thing, the question does not ask you to calculate change in speed. Question is asking you to calculate change in velocity. You have to be careful that velocity is a vector quantity. So change in velocity actually means change in vector velocity. Final velocity vector minus initial velocity vector. That is our answer. Had the question asked us to calculate change in speed, then it would have been a different question. This is slightly difficult one. Anyway, the first thing that we need to do is we have to find speed of the particle when it reaches B. In a question of motion in a vertical circle, if speed of the particle is known at any one point, if you know the speed, then you can calculate the speed at any other point by using law of conservation of energy. Just use energy conservation to find the speed of the particle at any other point if you know its speed at one point. In this particular question, speed at point A is given. We have to find the speed at B by using energy conservation. When the particle goes in this vertical circle, its total mechanical energy is conserved. It means when the particle reaches point B, it has got some speed V, the kinetic energy at B plus the potential energy at B, this is known as mechanical energy. Kinetic plus potential, this sum is known as mechanical energy. So kinetic energy plus potential energy at this point is same as kinetic energy plus potential energy at this point. It is same as kinetic energy plus potential energy at this point. It is same as kinetic energy and potential energy at point A. This is law of conservation of energy. When a particle is moving such that only conservative forces are working, only gravitational force performs work in this case. In all such cases, energy is conserved. So by using this law, I can find the speed at point B. This is how it is done. Let us say mass of the particle is m. Its speed at B is V. This is kinetic energy. Then potential energy. How do we write potential energy? For that, we need to take a reference level. Let us say we are assuming that potential energy is 0 at point A. When the particle is located at point A, its potential energy is absolutely 0. That is what we are assuming. Then what will be potential energy when the particle is at B? What is potential energy when the particle reaches B? From this point, point B is at a height L, isn't it? Point B is at a height L above A. So potential energy at B is mgl. This is same as kinetic energy at A. At point A, the kinetic energy of the particle is half mu square. U is a given quantity. What is potential energy at A? We have assumed it to be 0. Potential energy at A is 0. So just by simplifying this, we can get the value of V, right? So let us simplify this. M cancels out. You can multiply this by 2 and shift this term on to this side. It will become this much. V square is equal to u square minus 2gl. Therefore, speed at point B is under root u square minus 2gl. Now, important thing. If the question we are asking you, what is change in speed? Then change in speed is nothing but difference of u and v, right? But the question is not asking what is change in speed. The question is asking what is change in velocity. So how do we answer that? We have to understand that velocity is a vector quantity. This is final velocity in upward direction. This is initial velocity in horizontal direction. We have to calculate change in velocity, which is final velocity minus initial velocity. We have to do the vector subtraction. How is this done? This should be read as vector A minus B is read as addition of minus B to vector A. So Vf minus Vi should be read as addition of minus Vi to Vf. Minus Vi is a new vector that we have to create and we have to add it to vector Vf. Now let us draw a separate diagram. What is vector Vf? Vf is this vector. It is in upward direction. What is its magnitude? Its magnitude is this much. Magnitude of velocity is speed. So we know the speed, it means we know the magnitude of velocity at this point. So magnitude of velocity is speed, magnitude of this vector is this much only. Now we have to create a new vector minus Vi. This is initial velocity vector. If you flip it, if you overturn it, if you rotate it by 180 degree, you create a new vector that is minus of this vector. So I am creating a new vector which is minus of initial vector, minus of initial velocity. This vector has got magnitude u. The minus sign just tells you that direction of this vector is just the opposite of Vi. So this vector has magnitude u, but its direction is opposite to that of initial velocity vector. Now we have to add these two vectors. I have drawn two vectors keeping their tails together. So I will complete a parallelogram which is a rectangle in this case, and this is the sum of these two vectors. Sum of these two vectors is nothing but delta V. This is change in velocity. This is change in velocity. So change in velocity will have a magnitude. And the question just asked to find the magnitude of change in velocity. So change in velocity will have a magnitude that is equal to this square plus this square. What is this? What is this? This has got magnitude V. The square of this is this much. The square of this plus u square. So this is the magnitude of change in velocity, right? Had the question asked you to find change in speed, then simply taking the difference of u and v would have been correct. But the question is asking you to find change in magnitude of velocity. So please be careful about this. I hope you have understood this. The next thing that I want you to know, or I want you to recall rather, is that when a ball is being whirled in a vertical circle tied to a string, the string of length L, this small ball has mass m and it is being rotated in a vertical circle. The minimum speed that you must impart to this ball so as to complete the vertical circle is known to you all. This u minimum for completing the circle is under root 5gl, right? Am I right? Yes. So a question appeared in NEET paper just few years back, that this speed was not given as under root 5gl. Let us say this speed, I don't recall it exactly, but most probably I am right. The speed given was under root 7gl. This is not the minimum speed required to move this object in circle. It is more than minimum speed. So this object is definitely going to complete the vertical circle. Let us say at the lowest point, the speed imparted to this particle is under root 7 GL. Now the question is asking, what is tension in the string at this point? It is a very simple question. It actually does not involve any concept of vertical motion as such. You can say, I mean, none of the formulae that you have memorized is going to work. You just need to know the very basic fundamental Newton's law. What is the tension in the string at this position only? That is what the question says. So remember, I am giving you one tip. Just remember, in questions involving motion in vertical circle, if you know the speed at one point, you can calculate the speed at any other point. That is one truth. The next truth is that if the question says find the tension in the string, then at whichever point you have been asked to find the tension, you have to write the equation of centripetal force. You have to write the equation of centripetal force. Now at this particular point, it is very easy actually. You have to see which forces are acting on this particle. mg is a vertical force that is acting downward, and tension in the string is a vertically upward force acting on this particular particle at this point. Now the net force acting on this particle towards the center of the circle, net force acting on the particle towards the center of the circle is T minus mg. Total force that is acting on this particle towards the center of the circle is T minus mg, and this force must be equal to mu square by L. The total force acting on the particle towards the center of the circle must be equal to mu square by L if the particle is moving in a circle. I hope all of you know this. If a particle is going in a circle of radius r, then the total force acting on it towards the center of the circle is mv square by r. That is what I have written. Net force is T minus mg. That is equal to mu square by L. So the tension is nothing but mg plus mu square by L. Now assume a different question. I am slightly deviating from the question that was asked actually. Suppose the question says that in the same question, here you have to put the value of u, right? I'll do it for you. Just a minute. I'll do it for you. Otherwise, it remains incomplete. In place of u, you have to write 7 GL. So it will become 7 mgl by L. So this is 8 mg. This is the final answer. Okay. Now the next question that I would like you to answer is, please try to answer it on your own. Pause the video after listening to the question. Same question, the particle has been projected at a speed of under root 7 GL. What will be the minimum tension in the string during the course of vertical motion? What will be the minimum tension in the string during the course of the vertical motion? Students, pause the video, give it a try. I hope all of you know. If you don't know, please listen to it carefully. As this particle goes up, the tension in the string is reducing. The tension is decreasing. At the highest point, the tension is minimum. This is the position where tension is minimum. So when a question says, find the minimum tension in this string, that means you have to find the tension at the top. When a question says, find the maximum tension in this string, it means you have to find the tension in this position. This is the position where tension is maximum, and that is the position where tension is least, minimum. So I need to find the tension at this position. For writing the tension, we need to write the equation of centripetal force. But the equation of centripetal force can be written only if I know the speed of the particle at this point. So the first and foremost requirement is to find the speed of the particle at that point. And as I have said repeatedly, that speed of a particle at any point can be calculated using energy conservation if you know the speed at any one particular point. I know the speed here, I can calculate the speed at this point using energy conservation. This is how I am again teaching you how to apply energy conservation. Say this is point A and this is point B. So kinetic energy at B plus potential energy at B is equal to kinetic energy at A plus potential energy at A. Kinetic energy at B plus potential energy at B will be same as kinetic energy at A and potential energy at A. Again, assume that potential energy is 0 at this level. So this kinetic energy has to be calculated. We have to calculate this speed, half mv square. Now if I take potential energy to be 0 here, this point is at a height of 2L from this point. B is at a height of 2L from A. Therefore potential energy at B will be mg into 2L. Next, the kinetic energy of the particle at A is known to me, so I will write half m u square. U square means this square, so 7gl, and potential energy at A is 0. We are assuming that potential energy at A is 0. Simplifying this will give me the value of V. You can cancel m, multiply all terms by 2 and shift this term onto that side. If you do that, you are left with V square. This will be 4gl, and on this side it will be 7gl, so it will be 3gl, which means V is under root 3gl. So when the particle reaches the topmost point, its speed is under root 3gl. Okay. Now we have to find the tension. We have to find the tension at that particular location. So again, look at the forces. Look at the forces acting on the particle. The two forces acting on the particle are mg and tension. Now both the mg and tension are in same direction. Both the forces are in same direction. Both the forces are directed towards the center of the circle. Both the particles are directed towards the center of the circle. Therefore I can write net force towards the center is T plus mg, and this should be equal to mv square by L. Total force towards the center is equal to mv square by L. Now I know the value of V, it is 3gl root, V square is 3gl. Therefore if you substitute the value of V square, I am so sorry, the radius is not r, it is L. So let us write it as L. In place of V, if you write 3gl, you will get the value of tension. So this becomes 3 mg if you substitute for V. Therefore tension is equal to 2 mg. So tension when the particle reaches the topmost position is the smallest tension. At any other point tension is going to be higher than this. This is the smallest tension, right? When you project the particle at a speed of under root 5gl, when you project the particle at a speed of under root 5gl, tension decreases, and it becomes just equal to 0 at this point. If you project the particle at a speed lower than under root 5gl, if you project the particle at a speed smaller than under root 5gl, then what happens? The particle goes on, tension is decreasing, the tension becomes 0 somewhere here. If the tension becomes 0 somewhere, that means particle will leave the circular path. The particle will leave the circular path if the tension becomes 0 somewhere. If the tension becomes 0, it simply means there is no control of the string on the particle. Just picturize it like this. As long as there is tension, the string is stretched. But when there is no tension, it simply means actually string is loose. So when the string loses tension, the string is not applying any force on the particle. If I project this pen and ask it to move in a circular path, will it move? No, it will not move in circular path. This tension was actually making it possible for the particle to move in circular path. If that tension vanishes, then particle is not going to go in circle. So if you impart a very small speed here, the tension is decreasing, somewhere it will become 0, and if it becomes 0, after that particle is not going to move in circular path. After that, particle is experiencing only one force, that is mg. After that, particle is experiencing just one force, which is mg, and you all know that if you project a particle in air and only one force mg is acting on it, it will move on a parabolic path. It will do projectile motion. So after the particle leaves the circular path, it will move on a parabolic path. It will just move like a projectile. The string is there, but it is not tensed. The string has become loose like this. So the string is not applying any force. There is only one force mg. Particle is going this way. It will just move like a projectile. Why it will go in a circular path? So once the string tension is lost, the particle will move on a parabolic path. This could be a question. If the particle is going in a circle and the string loses tension here, what will happen? The particle is going to go in a circular parabolic path. It will just move like what do you say? It will just move like a projectile. Then there was another question in NEET paper few years back. It is a very common question that you usually find in your physics textbook, but that is what appears in NEET actually. In NEET question paper, you always get routine questions only. Very few questions in physics are actually, what can I say, new kind of questions. They are mostly picked up from some book or another. So this is a track. This is a track. It is a slide, kind of slide that you see in water park, etc. Right? And this is a smooth track. There is no friction. You leave a small block from here, and here the path is circular. Let us say the radius is r. The question is asking from what height should we release this block so that it completes the vertical circle? From what height should we release this block so that it goes in this circle? Now in this case, there is no string actually, but the particle is going in a circular path inside a cylindrical drum like this. Okay, the question is basically same. Previously, the role that string tension was playing, the same role is being played by the normal reaction of the wall of this surface. The normal reaction is doing the same thing that was being done by tension of the string there. If the string tension goes 0, means particle has lost contact, which means particle has lost the circular path. Similarly, if this normal reaction becomes 0, then particle is no longer on this curved path. It will fall following a parabolic path. The question remains same. Basically, everything is same, nothing different. So if the question says with what minimum speed that should be, at what minimum height that block should be released so that it can complete this circle, that means it does not leave the circle here. If the speed is so small that normal reaction becomes 0 here, it will fall like this on a parabolic path. So what height is the minimum height from which the block should be released so that it completes the circle? So all of you can answer this just by knowing that the least speed required at this point is under root 5g. This is the minimum speed required here. You leave the body from a great height. When it reaches here, it will have tremendous speed. In that case, it will definitely complete the circle. If you release the body from a smaller height, when it reaches here, it will have a smaller speed. It may not be able to complete the circle. So there is some minimum height from which if you leave the object, it will have this much speed at this point and it will just manage to complete the circle. So question is basically asking you to find the height for which speed at this point is under root 5g. Find h for which speed is under root 5g. So again, if I mark this point as A and this point as B, energy is conserved at this track is smooth. I will write kinetic energy at A 0, potential energy at A mgh, taking this to be reference level, this is 0 level. So potential energy is mgh, kinetic energy is 0. The body is falling, energy is conserved. When it reaches here, potential energy becomes 0 and speed that I want is under root 5g. So this is kinetic energy half mv square and potential energy is 0. So from here you get h is equal to 5/2r. So this is the minimum height from which you should leave the body, then only it will have a speed under root 5gr at this point, then only it will be able to complete the circle. If you release it from a higher height, then no doubt it will have much higher speed here, it will definitely complete the circle. If you release it from a lower height, it will have a lesser speed here, it may not be able to complete the circle. So thank you students for watching this video. Kindly share this video with your friends also, and if you have not subscribed the channel, please do subscribe. Thank you. Goodbye.